Hello, and welcome to my show. This is another live Thursday, episode 112, I believe. And I was thinking yesterday about the recent update to the M1 Docker desktop preview and wanted to give it a run for its money and trying to sort of play around with it because I hadn't done it in a couple of weeks. And right behind me at my desk, there's a M1 Mac Mini. And I can remote in from over here basically and kind of compare things side by side, talk about, and figure out some of the nuances. I have used it a few times for development, but it's not my main machine yet. But it doesn't have everything working. There are some rough edges, and I think we're going to have some rough edges for a while, specifically when we start talking about emulating QEMU, VPNs, low-level stuff, that requires system drivers, stuff like that. We're probably going to be, through 2021. I think the M1 is going to have a beautiful use case for like 95% of people, and that other 5% of us that really demand a lot out of our system. We're gonna wait for like the M2 or whatever, it might be years before everything is so noticeable. Basically, as a developer, you forget that you're on a different processor architecture. So, however, most things are good. Some things are amazing. So, I'm talking to you right now. Actually, this machine that's streaming is the top of the line 2020 MacBook Pro 16-inch with all the things, right? I think the only thing it doesn't have that would be more money is it has 32 gig of RAM, not 64 gig of RAM. But it has, the big SSDs. It has the i9 8-core processor. Of course, I am streaming, so it's working a little bit. I think the CPUs kind of hover around 7%, but it still sounds like a jet engine. In fact, my audio is running through a little software audio filter that filters out the jet fan noise that comes out of a MacBook. If you've ever had a MacBook Pro, you know what I'm talking about. If you want to compile or do anything, play a video game, something, it will burn your lap eventually. So that's been a normal thing. I've had these for a decade, and I'm used to that. Windows is kind of the same problem, especially on gaming laptops. But Macs try to pack so much in a tiny little frame that I tend to find that, and it's a metal frame, so it conducts heat a lot better. So I tend to find that it's really hot on your lap. You don't need a blanket or a sweatshirt if you're developing in Docker on a Mac laptop. But this M1 behind me, I've never heard it make a sound. Like, I was installing all the things today. I was updating all these things. I was adding an update to Parallels while I was doing a brew install, while I was starting up Docker. And it didn't make a peep. I haven't heard, as far as I know, you would never know it has a fan in it. So let's demo some stuff. First, I want to check out some questions. Like, let's catch you up if you're not totally up to date on what's going on the M1 platform, like what's ARM with Mac. This isn't just about Mac. I actually have Windows 10 on ARM also on this M1 Mac. It's not working as well as I'd hoped. It's kind of funky, and networking is a little spotty, and mouse movement is kind of weird. But we're talking about brand new architecture with a beta of Parallels with an insider beta preview of Windows 10 for ARM. So lots of betas and new stuff in that stack. The fact that it even runs and boots is, I guess, good. So I'm happy to demo things. One of the things I want to talk about is performance and possibly Docker desktop and QEMU. I've learned some new things from the Docker team in the last couple of weeks, some rough edges about, emulating Intel stuff on an ARM chip and how QEMU is not infallible. It is not the perfect emulation for architecture, and there are a growing number of things that people are finding don't work perfectly through emulation, like database technologies and stuff like that. So what do we got? Let me scroll through some of these questions, see if we can get anybody that has a question yet. Hello, everyone. We got Canada. We've got Europe. India. I guess it's middle of the night, somewhere close to middle of the night in India. I have friends in Bali, and I know they're 12 hours different. So, hello, everyone. Let's see, 2 queries real quick. Can I create Windows 10 and Win servers as containers on Docker platform? Second, what are the storage platform can I run containers on shared storage? So in order to run a Windows 10 binary or a Windows binary, a .exe file, you have to be running it on a Windows machine. You cannot, granted, there are, there's Wine, there's other platform emulation stuff, but we're not talking about that here because I don't know anyone that does that like for business. I'd say that those are more experimental things for home use or just trying to get your favorite old 90s copy of Windows Doom running inside of emulation. So yes, you have to have a Windows 10 machine. If you want to run a Windows container, you have to turn on Windows Container Mode, which I believe will then not use WSL2 because that's for Linux. It'll then switch it into Hyper-V mode. I actually haven't tested it lately. I'm still assuming it needs Hyper-V. And you can even look up an option called processor. I think it's called process isolation instead of I don't know what the other one's called. Hyper-V isolation. There's 2 different modes to Windows containers on Windows. One actually creates a full VM of Windows in Hyper-V, and it runs your app in there. Or the other one is it's just running on the host kernel in Windows 10, and that's process isolation. So you have to look at your Docker run commands. So step 1, turn on Windows Container Mode, which means you won't be running Linux containers right now. I have seen ways to run both at the same time, but that's beyond the scope of what I could do in a few minutes. And so you do that. And then the second thing is you have to do a Docker run if you want to use just easier process isolation. So that's what you would do. Second, what storage platforms can I run containers on shared storage? I would say any storage platform out there is going to have a solution for you. They may not work directly with Docker. They may be more focused on the CSI standard and integrating with Kubernetes because that's where people tend to use shared storage, right? You're not using typically shared storage on your local machine. Docker can work with NFS out of the box. So if you just kind of look up Docker run NFS, you can use a volume on remote NFS storage, which means like in cases of using AWS, you can use their EFS storage, which behind the scenes is actually running NFS. So you can do that. But any other storage platform, you're probably going to find them rapidly innovating on a solution that works with Kubernetes and Docker or just Kubernetes for server infrastructure. And they're going to have their own plugin, essentially, controller that helps you deal with that. Or they're going to have, it could be built into Kubernetes if it's been around long enough. They will have a built-in one, or it's an external plugin through the new CSI stuff. Anyway, so yeah, it's not a matter at this point of finding one. It's more like, what storage do you have available to you? And then figure out how that storage works with containers. It's not so much let me go look for storage that works with Docker. That's the opposite way you should think. Because typically, wherever you are at, you are limited on your storage options. Either your cloud has only so many options. For example, in DigitalOcean, you only have DigitalOcean block storage for file storage, as far as I know. And that is not shared storage. So you could not share it between nodes at the same time. So you would have to then find a plugin that works with DigitalOcean block storage for however you're going to run your containers. So hopefully that helps. Eric's like, I had the same laptop spec, added an eGPU for just that fan problem. Yeah, I actually bought the whole eGPU kit like a year ago, maybe a year and a half ago. I bought the top of the line kit with the Radeons. And it was actually slower at a lot of things. It was faster at some things, but because of that Thunderbolt connection being only 40 gigabits, I think it's 40 gigabits, it actually caused certain things sped up. Maybe gaming was a little faster, but rendering video actually got slower than using the built-in GPU. So I actually returned all my eGPU stuff, but it was quieter. And I processed a lot of video, so that was actually one of the important things for me. And I think it had to do with just going from CPU over to the GPU and back, and that slow pipe there. That's my theory, anyway. Hello, everyone. Pakistan, San Jose, Hungary. Bulgaria, Texas. Yeah, I've got some coworkers in Texas that are having dealing with the rolling blackouts, and I have a friend that actually hasn't had power in 3 days. So, stay safe there. Like, take a vacation to somewhere not there on the notice. Just impromptu, little weekend vacation or something. That sounds rough. I mean, us here in Hurricane Valley, East Coast, like we all have backup generators. We all have plans for water, all that stuff. Like, storage, lots of, supplies. That's kind of normal here because about every other year we have significant outages. But I know, like, Texas probably not used to that. So, what would be a good reason to run a Windows container? If you have a .NET framework app, a traditional pre-.NET 5 app that uses all of the sort of now legacy .NET stuff, the only way you're going to run it is on Windows. Or if you just have a .exe that you need to run. Lots of companies make lots of Windows products for servers, so those things all get to run in containers too. EKS better than Kubernetes? EKS is Kubernetes, so I'm not sure how to answer that question. Whenever you can run a cloud's version of Kubernetes, do it. Always let someone else run that thing for you. That's the reason we have the cloud. We got tired of running our own servers. We got tired of, patching our own systems. So the cloud helped us with that, helped us provision hardware. Now it's provisioning services for us like this. Like, you should always try to use a cloud's solution. So. Bret, I've been trying hard to get a secure Docker registry with authentication and working on the images. However, no success with HT password. Please advise the way forward. So yeah, HT password is like not in the registry image or something like that, if I remember correctly. So it depends on what you're trying to do. If you're just trying to learn a registry, don't worry about authentication. Like, if you're just trying to learn how registry works. I don't know people that tend to use registry latest in real world scenarios. Like, there are plenty of other options for free registries you can download. Just go look up actually the landscape on the CNCF. Let's see here. And let's go to cards. And we want to go to category. Let's see. Container registry. So just go here over to landscape.cncf.io, and you will see a bunch of projects here. Harbor I've used. It's quite popular. I think these are all maybe cloud-based. Then there's Kraken, which is an interesting one out of Uber that actually does replication of it. So it's a highly redundant system, and it works differently than just a single registry server. Portis is really just a GUI and management for the Docker registry. So if you are wanting to stick with the Docker registry, you could use Portis on top of that. But I would say check out Harbor. I feel like that's getting a lot of traction. I have not tried Dragonfly yet. But Harbor is the one I see a lot of Kubernetes shops using, and it will help you with a lot of that stuff out of the box, so that you don't have to manually deal with things like certificates and authentication and whatnot. I do have a few of those videos in my courses, but I do believe one of the issues with them right now is that HT password basically was removed from the image or is no longer in the sample image or something. So there's a problem with getting through that video. So I would say skip it. Like, how registry works. Once you've learned Docker Hub, you've learned all the Docker commands for working with Docker Hub, then just look at Harbor, because that's really what you'd be using if you were going to run your own registry, which honestly, at the end of the day, I don't recommend it. I recommend everybody use other people's registry, cloud registries. There's lots of them out there, and running your own registry is a bunch of work that you can avoid. So don't do it. Eric says we're past the worst. Okay, good. Got your power back, hopefully steady. I was on a call yesterday where, like, every hour, someone from the call from Austin was just, they dropped off the call every hour, it seemed like, or every 15 minutes. Can I run a container with a GUI in terminal mode? Yes, but it doesn't work out of the box. So you have to go look up X11, all that stuff for remotely connecting to the video server. Essentially, it does. So you just have to look up some blog articles on how to do that because it's not. It wasn't designed, like Docker wasn't designed out of the box to be a GUI app and management tool, right? It was mostly just about servers. So if you want to do that, you have to have a video server, essentially, something like that. There's probably some new innovative stuff that allows you to bind mount things and allow stuff to work. But generally, I don't do it. If you're gonna, to me, if I'm gonna run a whole GUI, then I'd rather run that inside a VM. I have seen certain Linux utilities. Someone in the chat will probably know. There are different ones that essentially what you'll do is you will run it in a container. It's a full desktop, but then you have to run it in a browser. Like you'll have to remotely connect to it through a browser window tab thing. So that's interesting, but it's not going to be something that I do every day, right? Like that's not. But then every time I say that, there's probably someone who has done it. Yeah, I mean, you can. Yeah, if you want to be Linux, you can do .NET Core, but there are probably millions of apps in .NET Framework that will take a decade to move to .NET Core. So, yeah, things, especially in the enterprise where .NET is at, move very slowly. So, I think we're all going to be dealing with .NET Framework apps on Windows for many, many years to come. Landscape URL. All right. Is it an anti-pattern to install an API gateway in Kubernetes? Some workers say that Ingress is for that. Ingress does not do API gateways, right? So Ingress is very limited. So what they're talking about is the default resource types. So when you're learning Kubernetes, you learn about resource types. And you have deployments, and you have services. And Ingress is one of those, and it's optional. You don't have to use it. What most API gateways, like if you look at GLU, GLU, or other Envoy-based API gateways, Ingress proxies, like most of them are not using the built-in Ingress provider, which means they're doing their own thing. Like they could do whatever they want. And those are what most people still go with. The Ingress provider built in is getting better. And it now has a few more features that allow it to be used in more use cases, but it is still not an API gateway. So I would say pick your tool, whatever your API gateway is going to be that you like, and then look at how they recommend installing it on Kubernetes, and that's how you're going to use it. It may use the built-in Ingress, but most likely it won't. So, in fact, all the ones I have used actually don't use the built-in Ingress. Like anything that's service mesh oriented or API gateway or advanced Ingress, like Traffic or Contour, whatever, all these things, they have a way to use the built-in Ingress, but it's always less functionality than if you use their controller. The Ingress is just a built-in resource. The main point of it is so that you can take your Kubernetes YAML manifest files and use them across different clusters that all have different Ingress controllers. But if they're all using the Ingress resource built-in spec, then you can take those same YAMLs and run them in multiple places, and you don't have to care about the implementation. A coworker of mine calls it the leaky abstraction problem of Ingress. So the goal is that your YAML works everywhere, but the reality is it doesn't. Like as soon as you start doing storage or any custom controllers, like it's out the window. You're going to have YAML that only works in that environment. So it's not a huge deal. I think most people have just, we realize that our deployments for our apps work fine, but it's all those other pieces of the puzzle that sit behind and in front of our app that tend to only work in a specific setup with specific Kubernetes controllers and resources that are custom. All right, let's talk about M1. That's why I'm here. So let's get the questions focused on M1. I'm going to do some stuff here. Let's see if I got... All right, so this is an M1 Mac. Sorry for the smaller screen. I tried to make it a little larger, but it's still a little small. So I'm on a Mac Mini M1 2020, got 16 gig of RAM. And what I've done so far. So I downloaded the Docker preview. That's over here. You can actually read about it on their blog. They announced yesterday. Is that yesterday? Yeah. They announced yesterday that they have a new release that now supports Kubernetes. So Kubernetes works. There's a couple of issues. There's some edge cases. Lots of subtle nuances in the differences of how these things work. The first one being, as soon as you do a Docker run, it's going to default to running anything. It's going to run the ARM version of that, the ARM variant of something when you do a Docker run. So we talked about that last month. I think I showed off that if I do a Docker run here, oops, well, I got to start Docker. So Docker is still in preview mode, but I had to replace it. It doesn't do auto updates in this preview. The previews are manually downloadable. I also have Parallels running in the background. Well, actually, I don't. These are all, I don't have Parallels VMs running currently, but I can have it running in the background. So Docker, actually, I think it starts a little faster than on my machine. It feels like it seems to start really, it takes like 30 seconds at least on my Intel Mac. So if I do that, Docker run -d, and then if I do a inspect on that container, no, and I scroll and I scroll. There we go. Oh, it says Linux. I should see it. Maybe it's only in the image. That's weird. I could jump into the container. Docker image. This is one of the feedbacks too, is that like we don't see in the screen, we don't actually see the architecture. We don't see the platform that we're using. So it's kind of hard when you've got different platforms running on your machine. It's not immediately obvious. So let's look at this one. All right, so this is the image, and we can see that it pulled down the Linux and ARM64, right? And then if I see this and I do a Docker is it A? Right there. Cut off. There's your ARM. All right. Now, if I do, let's see, if I do a Docker, this is a weird part. Let's see, pull. Is it platform? I think it's platform. Yeah, Docker pull platform. And I think it's Linux. I'm trying to remember the format. x86-64. Yeah. So now I'm pulling a new image that is basically the same version of Nginx. Okay, got to spell it right. And now I have two Nginx versions, right? And the weird part here is that you kind of have to go by image ID because if we go look, okay, that didn't work because that didn't. So if you look here, these aren't architecture, right? Because architecture isn't a tag. You could technically do that, but the idea behind Docker is that you could just run something, and the architecture is irrelevant because it's going to automatically pick the one that you want. So this one that I just pulled, I can't call it Nginx. I have to call it by its image ID. So if I'm going to run it, yeah. So if I do it now, if I do a list, I have 2 containers, and if I do a docker exec into this new one, f6d, oops. F6d. Oh, is that the right one? Nine. Two C3. Yeah, they're 2. Okay, so did I do this right? So maybe uname isn't the way I tell architecture inside a container. Oh, yeah. Oh, you're right. I did. Image right there. Thanks, Paul. All right, so let's try a third one. And this one, I'm going to use the. Okay, so what it did is it reused the tag. So this one is actually now the x86 one. And so it relabeled the tag, it moved essentially the tag or reused that tag. So the old one is now untagged because only one image at a time can use that tag. So the old one is untagged. So I could technically, if I did, this is the confusing part. If I do a run Nginx now, and so I have to do platform here, saying this is what platform I want to run it on. And this and I can type in here 64. So that's like these. There's 2 different ways to say it, and I think they both do the same thing. And now, so now I have it, hopefully, and this should be my x86 one. There we go. All right. That's what I expect to see. So, not super obvious. You can see I don't do this a lot. Usually I'm running, like I have a Raspberry Pi. I've played with some ARM servers on the internet. So when I want to play around with ARM stuff, I'm usually doing it on an actual piece of hardware and not locally in Windows locally in Docker Desktop. The Docker Desktop lets you do this back and forth on all the Docker desktops, regardless of what the host architecture is. But there are limitations. I hear that like MySQL doesn't work here. When you want to run the x86 version of MySQL, it doesn't work here, or something like that. I think that's the number one complaint right now, and that has to do with QEMU not emulating correctly all the things that MySQL needs. And you can see the official MySQL image. There is no image for ARM. So when you run MySQL, it's going to force you to run the x86 one, and supposedly it's not going to run. So let's try. Let's just see what happens. Well, if I don't specify a password, it'll exit anyway, but we'll see how far we get. Platform. If I just do MySQL. So see, it won't even let me, right? Because it doesn't find one for ARM. Now, I don't know. There might be another image somewhere that someone has built MySQL for ARM. There probably is. I haven't looked it up. Platform. And let's force it to use Linux. I'm gonna type it this way because it's more obvious. Is it 64 like that? Yeah. Okay. So now it's going to pull that x86 image, and it's going to try to run it. Supposedly this doesn't work. I don't know why. Now it's going to exit because I don't have a password. So as MySQL likes to do. So yeah, so I can just copy in that. Oh, so maybe the issue is that, well, no. So I've heard that there are issues, but I just don't know what those issues are. 6.4. Native AIO disabled. I'm not even sure if that's a problem on a real machine. I could run this on my regular Mac to see if those are. So it appears to be running. So I'm not really sure what the issue is, but maybe it's a performance thing. I'm not sure. But here's a great example of what I just ran into yesterday. So I have this sample app. Here's a problem that I think we're all going to have to start dealing with. Most of us haven't had to care about different architectures, but if you end up getting an M1 or you eventually get Windows 10 on ARM, you'll also have this problem because Windows 10 on ARM, as it gets more popular, will suffer the same fate. So I have this example repo here, and I have a regular Docker Compose file that builds a .NET Core app. But this is what happens when I do Docker Compose build. Actually, let me just let me prune. What is it? I need all. I'm going to clean up first just so you can see what this does. So my app, in theory, is cross-platform because it's using Node, it's using Python, it's using .NET Core. Like, it should just work, you'd think. But that may not be true. Do I see the platform going away over time? I don't see how you could ever do that. Because if you want to run QEMU emulation to run one platform on another, you have to specify it. Like, I mean, Docker could, technically, they could make a feature where it's going to try to run your native platform, and if not, it'll have a fallback plan of using QEMU with a different platform. But that's, I don't know, that seems risky to me because now people won't even know that they're running a emulated platform, and there's evidently just too many edge issues with emulation for that to be a done deal where it's just automatic. I don't think it's going away. We've had it for a long time. I don't feel like there's a sane way to just magically make it go away. But I could be wrong. All right, so I'm going to do a Docker Compose build. This is a very common app. This is the example voting app, my dog versus cats voting app. By the way, you'll notice nowadays when you install Docker Desktop on a new machine, it will automatically enable BuildKit by default out of the box, which is nice. So I'm getting the advantages of BuildKit. So it's doing a pip install, it's doing Python, it's actually building multiple containers in the background. It's doing a Node Slim download, and it's doing all these using the native ARM images. It's building them specifically, so if I was on my regular Mac and I did the same thing, if I came over here to my Intel Mac and I went into code, let's see, I think it's in the same place. Yeah. And I did a Docker Compose up or Docker Compose build. I should have timed them because I'm not really sure if it's faster yet. Some things are faster, some things aren't. So this is actually going to be using the legacy builder because this is sort of accepting the legacy default settings. So it's using the older, slower builder. This has nothing to do with ARM. That just happens to do with the way that Docker Desktop works now is when you install it, it defaults to turning on the build kit feature for Docker Compose. And on my old machine, I don't have that. All right, so I got an error. Canceled trying to download .NET Core runtimes and SDKs. Failed to solve with front-end Dockerfile v0. So basically means there's something in the Docker file that's wrong. No match for platform in the manifest. So it basically means that this image that I am using in a from, that image doesn't have an ARM variant. So the manifest file for that doesn't work on ARM because there is no image for ARM for that. Now, I'm assuming .NET Core works on ARM. .NET Core on Raspberry Pis is a thing as far as I know. And so the question is, what's my problem here? So basically, I have to go do internet research now to find an image that includes the manifest for both Intel, x86 and ARM images. And then I have to go and change my Docker file and make sure that there's no problem. So, not being an expert in .NET Core, I'd have to do .NET Core Docker image. And over here, so I have the .NET SDK, which, let's see, I need the SDK and the runtime, right? Because it's probably going to build with the SDK. All right. Now look at that image. Here, it only shows x86-64. It doesn't have a tag for ARM. So I'm out of luck. I'm not running this app on my M1 unless I can find some other variant. All right, here we go. Linux ARM tags. All right, so okay, so maybe all I have to do is specify 5.0, no? Or 3.1. So, I mean, this app was updated a couple years ago to support .NET Core 2. So, sure, it's a couple years old, but it looks to me like the only ones they're listing that are ARM are 5 and 3. And the way they have this working, you can't search by images because these images aren't really hosted on Docker Hub. They're hosted on Microsoft's registry. So let's just go see what happens if I break it. So 3.1. So let's just that's on the worker. Oh, this is the wrong machine over here. NVim. Oh, you know what? I'm going to use code because I want to tell you VS Code is wicked fast. I'm using the technical preview or basically the insider preview of VS Code because that's the only one that has the native for M1 universal package. It's code insiders. Okay. I know this works. I ran it a while ago. Oh, I must have not added it to my path. All right. Boo-hoo. So I have VS Code Insiders, and it starts pretty darn quick. Like that is way faster than on my Intel, I think. Probably half as fast. And I have a bunch of extensions installed, so it's not like it's just a pure way. It's got Docker, Kubernetes, the remote stuff's all built in. All right, so I need to go into my Docker file for the worker because I think the worker is .NET. Yeah, and down here, what was it? It was just 3.1. I think I can use 3.1. I think I have the Vim. Yeah, I have the Vim stuff turned on. All right. So let's see what happens there. Of course, I don't know if it'll run if 2.1 and 3.1 would be compatible, but we'll see. All right, so we need, let's see, that's for, well, it says service worker. Building worker. Oh, you know what? Are there 2 images listed there? Yeah. Oopsie. So in this image, sorry, that's really small. My apologies. In this Docker file, we do very typically when you're building these binaries, right? So when you do things like Go or Java or .NET Core, you typically will use multi-stage and you will build it in the SDK and then you will copy the output to a runtime only image that keeps your images small, right? And we can save that and then maybe it'll build. So maybe the moral of the story here is that if I was using more recent versions, it would have just automatically worked. Who knows? All right. Do you sense any heating issue when running multiple containers in the background for an hour? Intel is a serious pain. Well, on the M1, I'm running a mini. It's not a laptop, so. But every video I've watched on the internet says they do not get hot. Like all the laptops are. I mean, they're probably warm, but they don't get anywhere near as hot as the Intels. I think I saw a video where people were measuring the temperature, but like they use the little infrared heat camera to compare when they're doing a very intensive thing across 2 different laptops with the latest MacBook Intel and then the M1 MacBook Pro, and it's not near as much heat coming out of that thing, even at maximum effort. All right, so we built. Let's see if it works. It might just crash because .NET 2 hasn't been changed at all to be compatible with 3.1. All right, so other things while that's building, because it's got to download some of those. Other things I did. Homebrew works great. Visual Studio Code, as long as you're on the Insider Edition. Notice that when you're on the Insider Edition, you go there, and you now have this universal option, which you don't get with the stable release. My experience, though, is the Insiders are pretty stable, so it's not a horrible experience. And you can actually choose to just down a zip file or the universal. The universal is the Mac version of basically a package that's bundled both the binaries for Intel and for Apple Silicon. So go get that Insider release. This is the app. This is the example app that I'm about to be demoing. And then my ZSH worked fine out of the box. It's just shell stuff. And then we get to Parallels and running Windows 10 on ARM. So we'll get to that next. All right, so I should be able to go to localhost 5000 and then localhost 5001, I believe is the result. I can go over here and vote for dog. Yes, it's not working. All right, so let's see what happens. I bet you it crashed. Oh, sorry about the music. I had no idea that you were hearing that. That was an update to my streaming software. So Apologies on that. Hope you enjoyed it. All right. We're going to do a -D here. And I bet you it's just going to crash the worker is probably what the issue is. Yeah. So that's going to be me having to basically redevelop the app, right? Or update the app to support 3.1. And I'm not going to do that today. But the worker app, which takes the votes from here and turns them into results there, just crashes. So you can do like a... Oops. Yeah. Anyway. So that would be what I'd have to do there. Okay, so let's talk about let's talk about Windows. All right, so Parallels. Parallels has a free version. Right now, it's a free beta that for ARM, and you can't emulate Intel through Parallels. So a lot of this stuff, like with Docker and Parallels, it's not using... A lot of these things can't use the Rosetta 2 emulation on Mac, especially if they're low-level virtual, like for everything virtualization. As far as I know, there are no hooks to run through Rosetta for translating an Intel into a Mac or into an ARM. So if you're doing something like Parallels or Docker, a lot of the low-level stuff they have to build it natively. You'll notice some weird things though when you start to try to figure out what is running natively and what isn't. So like I just did earlier, I wanted to see what the ZSH version was that was actually installed. So this is the one that comes with my Mac, and it says x86-64. So does that mean my shell is running through Rosetta too? I don't know. And Brew, can I do Brew version? Okay, it's not specifying the architecture. But if I did, if I looked up Brew info ZSH, so I wanted to see like, is the ZSH that I normally install from Brew newer than the one that comes with Big Sur? And it turns out no, they're both 5.8. And what I don't know is if Brew, like, I don't know how to tell if Brew's aware of things that, is it going to compile from source, I guess, if I try to install that because it doesn't have a formula that includes ARM. I don't know. I haven't figured all that stuff out yet. But what is weird is like native commands have this thing making me think they're going through Rosetta, even though I'm on an M1, which is weird. I would think that those would be native, especially your shell. All right, so there's a guide that you can step through, but basically you download the Insider Preview, and it's a VHD, so it's not even like an ISO install. It's a VHD of Windows 10 on ARM. Now, here's a thing, though, that you can do here. So once we get this installed and working, there is a new feature that's beta on the beta that came out in the fourth quarter of last year that allows you to run x86 emulation on this ARM Windows machine. So technically, I don't need Parallels to do OS level emulation because Windows 10, kind of like Rosetta, Windows 10 can supposedly do that for some of the apps here. The problem I'm having, though, is, oh yeah, the performance is much better. So great. So, I'm now, let's see what this says. Yeah, ARM64 based PC. And I gave it 4 CPUs and 6 gig of RAM so that it would, run a little faster than the default. So now on here, the question is like, I think it's update. I think what I have to do is I have to turn on insider previews in here. And I have to link an account, and then I can get the emulation. That's what actually this, what this document steps you through, is you have to go through multiple steps. So once you've got Windows 10 on ARM running, supposedly in that particular version, which I don't think is an issue anymore, they had to disable time sync. But yeah, so you have to go through Insider Program and then do updates and then go to Beta Channel. And that will get me to x86 support inside of ARM on Windows 10 running through Parallels on an M1 Mac. But I haven't done that yet. So that's the next thing I want to try. But I'm not sure how much I have to as a developer. Granted, all my desktop apps like on Windows would be problematic. But like VS Code, does that have an ARM variant? So I bet you it doesn't have. Okay, here we go. All right, so this is the ARM version of VS Code. So ARM64 VS Code setup. Yeah. And then, of course, if you're running Windows, you you want Microsoft Terminal. So go get that. And that's just going to be in the store. And all the store apps, as far as I know, well, maybe not all of them, but all the ones I was looking at are the last time I did this, they worked. But they were the really simple apps. So I didn't try games or anything. All right. What else? What questions have we got? VS Code integrated Git. It takes a while to check the repo status. Yeah, I guess that would depend on the size of the repo, right? I haven't experienced any of those issues. But I tend to use like GitHub Desktop or the Git client. I don't tend to use the Git tools heavily. That's not true. I use it for merge conflicts in VS Code, but I don't have that experience. So, if your workspace has a lot of folders using Git, okay. So if you've got multiple apps, microservices, something like that, okay, I can see that. So I'm basically ready over here. Like I've got Docker running, I've got VS Code running, I've got Parallels running with Windows. Now, there is no Docker desktop for Windows 10 on ARM. But as pointed out on the internet, on GitHub, you can actually just download the Docker binaries. Like those exist for Windows 10 ARM. And you can run those. So you wouldn't have the full Docker desktop experience, but you would be able to technically run Docker in this. However, I don't think WSL2 is going to work because that requires nested virtualization. And so far, Parallels does not have nested virtualization. So for example, if you go into Parallels on Mac and you look under device, no, that's the preferences. I need to go into, so the hardware here, like CPU and memory, and there's no, oh, what? It wasn't there last time I checked earlier. Enable nested virtualization. All right, well, let's see. I'm going to see. Let's see if that works. Last time they said it wouldn't, so let's, I'm going to shut it down. Yes, Conrad, yes. So Parallels allows you to run apps basically outside of the GUI. So like a Windows 10 app would look native on a Mac. That's just a standard feature. So it's grayed out. I'm not sure that if that means it's never going to work, or is it a red herring? I don't really know, but it's grayed out. Let's see if I close it and reopen it. Yeah, it's grayed out. The last I read is that nested virtualization isn't a thing on ARM Apple M1s yet, like something to do with the Apple hypervisor. I'm not sure what the real reason was, if it's Apple's limitation, if it's a processor limitation or what. So that's not possible. So what else do you want to see? I've got... I am curious about what is the issue with the MySQL. I'm going to have to look that up. Ask the team. Anyway, if you don't have any more questions on the M1, I'm going to wrap this up. Although, I guess I could do a performance test, like if anyone cared. So let's do something on Docker Desktop. Let's do a build. And I'm going to do it at the same time on both machines. So we're in the same app. Let's see, Docker. Let's do a Docker system prune FA on both of these. And then I'm going to try to hit enter within a second of each other. So it'll have to pull down all the images. And these are both on gigabit internet. The only difference is the i9 is using about 7% of its CPU right now to have me streaming. So that's what my system is doing right now. So Docker, we're going to do a Docker Compose build. Now on this one, I need to enable the new Docker Compose build stuff. So actually on this one, we're going to do Docker space compose space build. And that's what we're going to do over here too. Yeah, so Paul's thinking that maybe the only issue with MySQL is that it's just there's no native ARM build. So in your, if you wanted to fix that here, you would have to, what you could do, we can test this in a minute, but what you could do is you could actually create, if you're someone who's on an M1 and your team is not, they're on Intel, you could create a docker compose.override.yaml file, and you could specify the platform inside of the compose, I believe. I thought we looked this up last time, and I thought you could do it, but we'll have to check. I want to see if that's possible. So once you pull the MySQL image, if you pull the platform of that image, then I think Docker Compose will just use that image and launch it correctly. I could be wrong. I want to check that out actually. So this is what I'm going to do. I'm doing Docker space compose space build, which will use the new built-in compose that Docker is building into the Docker CLI. So this isn't the Python old school Docker dash compose. This is the new one. And it's going to use the new build kit. And I'm going to hit, let's see, enter. All right, so they're about a half a second apart. This is my Intel Mac. This is the M1. By the way, this Intel Mac cost me about 3 times as much as the M1 Mac. Granted, it's a laptop and it has batteries and a screen, but of course, I am building on .NET Core 3 on this one, so I don't know if that'll change the speed. So we're on step 29 over here. We're on step 28 over here. Oh, Intel's in the lead on step 34 of 36. 32 of 36. Okay, we're done on the Intel. So the Intel, did it not give me the final? I thought build kit gave me the final. Yeah, so it took 64 seconds, 64 and a half seconds on the Intel, and 76, so 12 seconds slower on the M1. But may not be a fair fight because that was using .NET 3. Anyway, so the thing about the I'm going to bring these up real quick. Let's see. So my DB is running, right? So if I look at the compose file, the DB is Postgres, not MySQL. That's why. It's Postgres, which Postgres does have a ARM variant. So if I do a Docker manifest inspect Postgres, I couldn't remember if it was manifest inspect manifest. Okay, so this is the manifest file that comes out of Postgres, and it's got all these options, right? Like we've got ARM, we've got the AMD that everyone's using. We've got ARM v7, ARM v8, 32-bit, 386, MIPS, PPC. Like it's all of them. 390X, like basic, or S390X, all the mainframe stuff, all the 32-bit stuff. So you have all that with Postgres. But if I did a quick little sample, I'm going to get out of there. And let's see, MySQL. So if I don't think I have do I have nvim installed? Let's see. So if I just bring up this file and I do services, MySQL, it's going to really not like this. Spaces, image, MySQL. Actually, do they have a compose file here really quick that I can use with the password? There we go. Oh, also, I want to get my favorite Vim on this thing. So, can I brew install space Vim? Yeah, I didn't think so. All right, I want to get my favorite Vim distro. Give that a second. Biker. Yeah, it's complicated, and Docker can definitely do a lot more to simplify it. I think by bringing more things up, like showing you which the like just having a column of the platform name in there. Yeah, it's not going to work. Trying to get Space Vim installed. Let's try it again. 1. Okay, maybe that was it. All right, so let's copy in. We're done with that. Let's copy in. Where'd it go? Oh, did I let's see my page. Sorry, lost that page. All right, so we want this example. By the way, you don't need the version anymore. I don't know if I mentioned that. You don't need the version of Docker Compose file. All Compose features work together, whether it's version 2 or version 3. You can leave it out as of like 6 months ago. All right, so Docker Compose up. What happens here when I do this? Okay, so it looks like it used the one I downloaded, but if I do a Docker, what happens if I do a Docker system prune? Manvindar, so yeah, your thing on ARM. So right now, the Graviton in AWS, the Graviton Gen 2 processors are more, if you can get your code running on ARM, it is cheaper per, basically, per performance. I don't per, power per watt, whatever the calculator is. Basically, they're claiming you can get up to 40% better performance for the same amount spent on a VM in AWS. So the fact that they're on Gen 2 now, because Gen 1 wasn't that great, it wasn't that, and the prices were a little higher, so it wasn't that big a difference. Like basically, you were going to spend the same amount of money to do the same amount of work, in my mind, when I was looking at the analysis and the results. Sure, you could get cheaper instances, but they were slower. So most people, don't want a slower server. So the other thing about the Graviton 2s in AWS that I really like is that they start with really fast networking. I think they all have multi-gigabit, if not 10 gigabit networking. So you can get better networking at a lower price point, which typically you have to pay a lot of money for with the Intel VMs. And networking on a distributed system is pretty important. So, all right. So the whole point of me doing this was I want to do a Docker Compose up and see if it fails. Okay. That's not what I wanted to do. Docker PS. Okay. So Docker... I'm running all these things. So let me stop the MySQL. Just going to kill MySQL 864. Vote result. All right, just killing some of these things. All right, so yeah, because Docker won't delete the images if there are containers running it. So now I'm going to do another Docker system prune all force. Because what I don't want to have Docker image ls. When I do a Docker image ls, I do not want to see the MySQL image. So there's one of these things that happens in Docker, and I believe this is the case still in this situation, is if you download an image with the -- platform, so if I download MySQL specifically as an x86 image, other things that depend on that, like a Docker run or Docker compose, I do believe they will just use that architecture of the image. As long as the tag matches, they will use the one you've downloaded. That was true. That was true back when we were doing Windows. There was a mode where you could do, on Windows, you could do Windows containers plus Linux containers, and that was basically the same thing. You had to choose your platform, only at this time it wasn't a CPU architecture, it was the OS that was the difference, right? The architecture was still Intel, but it was just Linux versus Windows. So the way you did that is you downloaded the images manually, and then all your Docker commands would work for that image to specifically be on Windows or Linux, depending on which one you wanted to be there. So I don't know if that's still the case here. So if I do a Docker compose up, yep, okay. So this is the problem, right? So in my compose file, it's trying to download it doesn't see that there's an image. So it says, hey, let's pull the image. Oh, I don't have your image in the manifest. And I'm not sure that the pull command, like it doesn't take QEMU into, it doesn't look up whether it's got QEMU support for that particular architecture before choosing some different architecture to download, right? That's more of a Docker run thing, that it basically injects QEMU right before your container starts so that it can do that emulation. But with a pull command, I don't think there's the intelligence there, and I don't know for a fact. I haven't looked at the code. But the pull command is where we're getting hung up on. Is back in the background, Docker's trying to pull an image for a particular architecture that's not in the manifest, so it doesn't know what to do. I do believe compose reference. I'm just going to try this. So we're going to do a nvim docker compose. There we go. We're getting some of our. All right. So platform. I don't know if that's going to work. But let's try. No. No, not image. Inspect. AMD 64. So let me just make sure that that is exactly. Oh, you know what? I might have to say that. Maybe it's the wrong format. All right, one more time. Nope. Nope. No matching manifest for Linux, ARM. Oh, right. Duh. I'm a dummy. Linux. Oh, so it's not. Okay. No, it was correct here. That was actually correct, but it's not recognizing the platform. So maybe this is just not a feature of Compose yet. Project profile. Yeah, there doesn't seem to be a way with Compose for me to specify a different platform. That is oddly missing. Oh, look, there's platform. It's in the version 2 file. Target platform containers for this service. Platform, Linux, ARM. So all of these, yeah. So it should work. What if I put a version in there? Let's see, what are people saying? A clipboard manager? Yeah, I use Alfred. So, yep. Biker, on the parallels option, deselecting the other parallels option. Yeah, I could try that. Oh, that's the wrong screen. Yeah. Adaptive just means that it's going to, if you're not using the app, it will put less performance emphasis on, like, if it's not front and center. So they're not really related. Yeah, it just doesn't. But the weird thing is it wasn't there before. Yeah, I don't know. All right, so one of the things I want to do over here was try to get this working by putting in a version 2.4. And then use old Docker Compose. Oh, okay. All right, I got you. Okay, so it's pulling it. Well, it looks like it's doing it. Okay. So Docker image ls shows MySQL. So let's do Docker image rm MySQL. And now let's do a Docker. So this is the new Docker Compose pull. Remember, there's a space here. So the old one worked. Okay. So this is, to me, this is a bug. So yay, I've discovered more bugs. And then the last thing I guess I want to do here is I want to take that version out. Let's oops, no. Let's comment out that version because it shouldn't be needed. And then I'm going to do the old Docker Compose pull. Okay, got to type pull. So yeah, so it works without the version in old Docker Compose. So the new Docker Compose doesn't support all these other options. So the question is if I go to the Compose specification, which is, we're no longer versioning Compose files, and that's because they're all following what's called the Compose spec, the Compose specification. So platform, they say platform a lot here. Platform. It's all talking about platforms, not in as in architecture. CPU period. Out of memory killer. Okay. So yeah, platform must use the target platform containers. Yep. So yeah, it should work. Linux AMD 64 should totally work in there. but it doesn't. So that we need. So you can see that the new CLI here talks about filing an issue. So basically, all we got to do is jump over here. Let's see if anyone's created an issue for the platform. Add platform when running containers. Yeah, so I'm not sure if anyone's filed. What I did, added a platform flag to Docker run only shown for local context, add the platform to gRPC. I don't see how this is related. So yeah, I'll have to file that. And that's not something that's exciting enough for live streaming. All right, so I'm going to wrap this up. What are the last questions we have here? Yeah, so the PyMySQL. Yeah. Max, no, you cannot run Docker in Windows on ARM now. I mean, you technically can. You can download the Docker daemon binary and the Docker CLI binary, but there is no Docker desktop for Windows 10 on ARM. And I don't know that they're even working on that. I think that Windows 10 on ARM platform has to get much. It's probably going to have to be a stable release with a lot of people using it before Docker. Like, because Docker gets requested to have Docker desktop on Linux, and they still haven't done that. They've been asked to do that for like 3 or 4 years. So we're going to have to see a lot of people requesting Docker desktop for Windows 10 on ARM before Docker will start working on that platform. The difference there is that Apple said, oh no, in 2 years, all of our machines we sell will be M1. So Docker had to do that. With Windows 10 on ARM, it's still a very, very small slice of the people buying Windows machines, right? So how can I see Docker API calls with Docker CLI commands? I don't know. There's Docker events, and you can turn on Docker debug in the daemon. I'm not sure if that will list you every API call, though. So I have a poor network connection, so why do you have MySQL in prompt? Rewatch the show. When you get a better internet connection, watch the show. We were testing MySQL x86 on an ARM machine, so hopefully that's what we were working on. All right, thanks everybody. I'm going to wrap this up. Been here over an hour playing around with the M1 and me struggling with some of the nuances of how to get Docker to work as expected. And we found a bug. So I'll be filing that hopefully today. And hopefully we'll get that working so that essentially you can specify the platform in your Docker Compose file, and then it will run that. So for your MySQL images, you essentially can run the x86 variant on your M1 Max, or on your Raspberry Pi if you want to run MySQL there, or run an alternative image like the I don't know if it's Hyperiot or Hyperiot. I think it's Hyperiot is how you say that. That group of people, they're all ARM pirates essentially, and yeah, have a good one. I'll be back next week. We're working on a couple of guests for this. I don't think it's next week, but the week after we're gonna start having guests again. We're stacking them up in the list. So join me next Thursday. I'll be back live on the internet. Ciao.